chairs around, guys. So when you go to the computers, go and swap them around again. Guys, can you please not go straight to the back? You try and do the one of this is back.
Someone says, oh, it doesn't touch it.
Okay. Sorry? Alright, so when we're looking at computer programs, a big problem that people have straight away is thinking about the way we deal with information. Now, with most programs, there's three parts of our data. There's the input, the output, and the process. Okay? And you really have to be conscious about how we can get data in, how we can get data out, and what we can do with it. Can someone suggest a way that we can get data into a computer or a computer system or a program? Spreadsheet. So how does the spreadsheet actually get in?
Just insert the data into the spreadsheet.
How do you insert the data into a spreadsheet? A keyboard. Okay, so we can type data in with a keyboard. So we can get data in with a keyboard. What else do we get data in?
Mouse?
Mouse? Yep.
Video.
Or if you can't think of a way to get it in, how can we get it out? How can you get data in with a video? So I watch a video on my PS3, and while I'm watching it, it soaks through the airstreams and goes, and I'm going to go to my computer and I go, wow, that video is there. How can we get data in, or how can we get data out? Thanks. A monitor could be a way of getting data out. Beg pardon?
An audio jack.
An audio jack. Is that what you do?
Headphones.
Headphones? Speakers? Now, look, you might think I'm being pedantic and being very literal, but there's a reason for it. Because some people get into their program and then I go, well, how do you expect to get that? They go, no, what do you mean? Because I haven't actually been very literal and thought about how do I put the data out to the user? Or how do I get the data in from the user? Is there any other way we can get data in?
Microphone?
Microphone, excellent. And somebody said, oh, an input device.
The camera.
A camera?
That's what I meant by video.
What is this, how you say webcam? A camera? USB? Any other ways of getting data in? Any other ways of getting data out?
Like an MPD that you can take out data out from it. So, say you have a DVD, you put it into the computer. Yes? No?
Okay, yep. So a drive of some type, like a DVD drive, yeah? Okay, you can also get that out that way. Yeah, because somebody else said something just a couple of minutes ago before at least started talking. Started with P. Someone said something started with P. Yeah, thank you. Printer.
Also another.
Yes.
Which is scanner.
A scanner is in or out of
In back.
Okay. So here we've got a few ways we can input. Here we've got a few ways we can output. Well, what can we do with the data? We can input it, we can output it. Are we just outputting what we inputted? So if I put in hello and I just get out hello, is that any use? Do I want to get out exactly what I put in? What might I want to do with it? We normally say data in, something out. Data in, that's coming, and what comes out? The process doesn't come out. You jump one question.
The result.
Data in, but what comes out? And we do some information data in, information out. And what do we do to that data to make it into information? We run it through a process. Now, we might do some kind of calculation. Somebody give me an example of a calculation.
9 plus 10.
So an addition. Anything else?
Subtraction.
A subtraction.
Division.
Multiplication.
Okay, so multiply. There's lots of different things we can do to it. Okay, so we've got data that gets in. So you've got to stop and think, okay, how are you going to get that data into the program? What am I going to do with that data? Am I adding it up? Am I dividing it? Am I multiplying it? Am I working out the average? How do you work out the average of something? Is there anybody here that doesn't know how to work out the average? See, that's why I hate people having those wheelchairs and swivels, because when I'm teaching and talking, I was getting I'm starting to feel like I'm back on the fair star in 1988. Yes, I'm that old. Got off, had sea legs for 7 days. Anyone been on a cruise?
What is it?
A cruise. You know, a cruise is a big
I
boat
know
on the
it's
water.
Yeah.
Submarine. You get the sea legs, and when you get off, you're going like this, even though you're old man. You're right.
So the day I was on a rave on a boat, does it count?
Yes, but you wouldn't just be rocking, would you? If this boat's a rocket, don't come and knock it. That's an old song they used to have on the pedals. Okay, so input, process, output. So how do we get stuff into our system? What do we do with it? And how do we get it out? I ask anyone know. Does anyone not know how to work out the average of something? Colin, do you know how to work out the average of something?
Yes.
Does anybody not know? You?
I do not.
Okay, tell me how.
It's like you add them
Like.
all.
It's not like, it is.
It is. You add them all and you like divide how much you added.
I know what you mean. Yeah, you're right. Okay, so good. All right. So you just add up the total and you divide by the number of schools. Okay, that's good. That's the average. And quite often in this course you'll be asked to work out the average or something. Okay. This is very similar to an IPO chart. Okay? It's one of the tools you have to know how to use. You'll have to reproduce it. Okay? Feel free to take notes whenever you want. Okay? IPO. Input, process, output. So we've got a particular problem. We list down the inputs that we're going to use. We list down the process we're going to use. And we list the outputs that we're going to use. For example, if I ask for you to enter 2 numbers and work out, just simply add them, what do you think my input, process, and output would be? You know what? What would be my input? I lost you already. 25 past 3 already. Wish I was what's the regular show.
Just the audience you asked.
What a guy. Was that adventure time? I get confused between the two.
Everybody.
You watch them.
Who doesn't?
I don't. I don't. They drive me mental. If I was going to ask you to write a program that works out the total of 2 numbers being added, what would be our inputs, our process, and outputs?
Numbers. Endless numbers.
Endless numbers.
Any numbers.
Any numbers.
Addition.
Any numbers. Okay. Here's our first problem. Any numbers. So what would our process or our output be?
More numbers.
Sorry?
More numbers.
The output would be
The output would be
a different number.
a different number.
If you put it through an addition process, it will be.
Right, so what could we call that? Total. The output would be the total. Do we still think we want any numbers in? So what's our process then? Jesse, what do you think our process would be? Addition of what, right? We just want to add the 2. So our addition of what? Okay.
The addition of the input. What do you?
Why are you inputting?
That's what I'm asking you.
It's a double D. So.
Addition of any numbers?
specific numbers now.
Specific numbers, okay. So it's getting a little bit ambiguous, isn't it? Any numbers, what numbers, these numbers, two numbers. So what do we have to do? So it's not so ambiguous, so it's specific. If I said to you, hey, do you come here? Stand up, please. You. Well, who am I talking to? What would I use? A name, okay? Or if I said to you, go to the pantry and go and grab me that can, which can would you know to grab? What's on a can?
Labels.
Label. Okay, so we need to use a name or a label. Okay, so we can't just write any numbers there because it's too ambiguous. Anybody want to make something up, a way that we can refer to these numbers, a label that we can give them? So we're just adding two numbers.
Number A, number B.
Number A, yeah, and letter 3 and letter 4. Yeah, no, you're okay. That's good. Look, we're going to change it number 1 and number 2. Beautiful. Now we can say process. Now you might think I'm being silly by being so pedantic on that word again, but it's actually, I want you to be aware of it. Okay? Because sometimes you'll write programs and I'll say, well, how do you expect the user to put that in? And you go, and if you don't get it, if you don't get that bit from the very beginning, you're going to struggle for the next 2 years. Okay? When we're writing instructions, instructions need to be really specific. Do you remember those instructions I gave you last year, Toaster Week?
Yeah.
Okay, so the instructions need to be specific. When we're writing computer programs, we are writing instructions for the CPU. Okay, the computers aren't smart, they're just fast. Okay, and they can do redundant, repetitive tasks, and it's up to us to tell them what tasks they can do. Okay, so the computer is not smart, you're the smart ones because you're telling it what to do. Okay, so we've got number 1 and number 2, so we say add number 1 and number 2. And then output we could say print total. Is that okay? Does that make a bit more sense now? Okay, we'll just say our first IPO chart. Again, feel free to take notes. If you get an examiner, you'll be asked, write an IPO chart, or what is an IPO chart? And there's lots of diagrams in this course. I don't want you missing out marks on your simple diagrams. That will make it very annoying. Anybody doing IPT? No? Okay. Well, look, there's lots of diagrams in this course. You've got to know that. Okay? Look, I'm not forcing you to take notes. I just don't know why you've had 2 lessons where you had it pretty easy. Now I start delivering some stuff you're not really worried about writing it down. Okay, so we said we want to give these labels so we can refer to them. Now, in maths, we quite often have labels for numbers and we refer to them. What am I talking about? So I'll give you an example. We want to work with a number. We're not too sure what the number might be. What do we use? Sorry? A pronumeral. What's another word? What do you call it when you're using letters? And you're adding them and subtracting them and squaring them using polynomials and hyperbolas and all that. Is that what it's called? Hyperbolas? Parabolas? Parabolas? Really? You don't do that? What do we call when we use letters instead of numbers?
Algebra.
Yeah, algebra. Okay. So we use it. We have algebra so we can refer to something when we don't know its value, so we can handle it, so we can deal with it. Okay. So in this case, we've got 2 things called number 1 and number 2. So we've got these 2 numbers. We don't know how big they are or how little they are. All we know is that we can refer to them as number 1 and number 2. They might be the same value. They both might be number 3. They both might be number 3,600. We don't know. Okay? But what we do know is that they're a number. However, there's different types of numbers. Can someone tell me a different type of number? Or a type of number?
It's an integer.
What's an integer?
Single digit number before the decimal place. Well, not necessarily.
Say again,
It's a whole number.
Oh, that's a bit different what you just said. You said a single digit number before the decimal point. An integer is a whole number. So it's not 3.2, it's not 3.7, it's not 3.9, it's 3. Okay. What's another type of number we can have?
Well, let's float.
Float? Yeah. What do you mean by that? Explain to the class what do you mean by float. Well, what's not?
It's like, well, you can have decimal points which is possible.
Oh, give me an example.
I don't know, 16.
Get a 16.2. Okay, we don't actually call that a float.
That'd be like,
So we call that a real number. If the number can have a digit or a fraction, we call it a real number. So it might have a fraction. Now, a real number, if we say something is a real number, it could still be an integer. However, we can't say an integer can be a real number. Does that make sense?
yeah.
So if I say x is an integer, it can only be 3, 7, 26, etc. If I say y is a real number, it could be 2.4, it could be 3.78, it could still be 7. So a real number can have a fraction or no fraction. A real number can still be an integer. An integer can't be a real number. An integer has to be a whole number. Any other type of numbers we can deal with? No, that's okay. We can build on that. So at the time, at this moment, we're just looking at numbers. But what if I didn't want to deal with numbers? What else could I use? What's something else I can play around with?
Letters.
Letters. Okay, good. An example?
A, B, C, D.
A, B, C. Okay, so quite often in computer terms, we don't call them letters. What do we call them? Characters, okay? Or char for short. Char, short for a character, okay? So it's one letter. What else could we use? Not just letters. What if we have lots of letters? What if we have lots of letters? If you put four letters together, what does that give you normally?
Word.
A word. Yeah. Word. Yeah. Okay. Right. And if we put a few words together, that could be lots of words. But what did you say? Someone whispered it.
Sentence.
Yeah, sentence. Okay. So, but we don't call them a sentence, even though it sounds great. We don't call it a sentence. We call it a string. If you anyone watch the Goodies? Strings. Yeah. Do you remember the string episode? String. Everybody. You're killing me. You must be the Period 5 tigers. By the way, when we have this period, I don't mind if you bring your coffees or something, or your V's or something to perk yourself up, okay? Period 5, I know it's a bit of a... Okay, so a string is a bunch of letters. Okay, so these are types. They're types. Okay. Now over here we call this number 1 and number 2. We gave them names, we gave them a label so that we could do something with it. And here we're going to actually add them together. So our process would actually just be this: number 1 plus number 2. It'd be very messy with it. Number 1 and a number 2. And maybe even a better way to write that would be that our total equals number 1 plus number 2. Okay. So now we've actually got a little bit of a algebra equation there. We're saying, hey, I've got something that I've called total, and its value is this thing plus this thing. And so then I'm going to just print that out. I don't want to print out number 1, and I don't want to print out number 2, but I want to print out the addition of the two of them. Does that make sense? Is this too boring, mate, isn't it? Too boring for you? You want to have the first term off and then come in? Did you know all this already?
No, that wouldn't necessarily be too bad for
Okay. That's right, mate. You just got to hang in there. Okay. So I said we've got these cans in our pantry, and I said, how would you know what they are? You said they're labels. So what I like to do, I like to actually think of them as cans. because when we input this stuff into the computer, it doesn't just sit on the screen. It actually gets put into the memory in the CPU. Okay? So the memory holds these two things so that it can do an addition with it. So I like to have this to represent the memory. So on this one here is called a number 1. This one here is called number 2. And they're the same type of things. This one's tomato soup, that one's tomato soup. Okay? They're just two different cans. If this one's baked beans, then that one's baked beans. They're the same type. Because I don't want to be adding baked beans to milk. You know what that's like, okay? And so I just put little symbols on the top. You know, you've heard that saying, oh, they're like a square peg in a round hole. Louis, I'm sure you've heard that said to you a few times. No? Square peg in a round hole. It means you don't. You know, what's it mean, Jess? What's that? Oh, think about it. It doesn't fit, Ellie. Exactly right. You try to put it. You know, remember that little toy you used to have? You must still have it. You know, the one's got the holes in. You put the shapes in there, and at the end you pull them apart and it'll let you curly. Yeah. No. Yeah. Okay. So if you've got to try to put a square peg in a round hole, it doesn't fit. So when we set up our program, we needed to say, okay, here's the labels I'm using, but they're this type, and I've just drawn some symbol. They're this type, and the only thing that can go into these cans, these containers, is something of that type. What type can I say? I could say they are integers. So I could say number 1 and number 2 are integers. So that means only integers can go into them. If you try to put a real number into it, you get in trouble. Your program will probably say, hey, you've got to type mismatch. Okay? We could say they're real numbers. We could say they're strings. I'm trying to put words into them. If they're strings and I'm trying to put numbers in, I might have a problem. If they're numbers I'm trying to put strings in, I might have a problem. Okay? So I've got these different types. So now that I can put something into them, and then I can do something with it. Okay, so now someone besides you two guys, someone tell me, how do you think we might get a value into this can? And this is where people get stuck. They know they've got the can, they know they want a number in there. What part of this IPO do you think we might be using? You think we might be using an input, a processor, or an output to put values in? Input. Input. Okay, so we'll be using. Okay, so how do you think? So we're going to do an input. Is it you, Eli?
Me.
Good work, Eli. Okay, so we're going to use an input. So how do you think we might get them in? What type of sentence do you think? What type of command might tell us how to get these numbers in there? Control P. Copy. You have to do that to a spreadsheet.
So please elaborate.
No, I want you to have a guess. Don't just sit there and go, I don't know, so I'm not going to say it. Because it doesn't hurt if you get it wrong.
You press a key.
Yeah, you press a key. Okay, cool. But what type of sentence can we use? See here, I've got a number sentence here. Total equals number 1 plus number 2. What do you think I can do to make number 1 have a value? Yeah?
Number 1 equals 5.
Okay, so you could actually have something like this. Number 1 equals 5. Okay, now, in normal maths, this thing here says whatever's on this side is the same on that side. That's maths, isn't it?
Yeah.
You could even say 2 plus 3 equals 10 over 2. That's fine, isn't it? In computer programming, that's the equal sign is not the seesaw. Okay? When we use sentences like that, what it actually says is this thing here on this side, on the left side, this now takes the value that's on that side. So we take this and we put it into there. Okay, so when we see that, we're saying take this, make this thing equal to that value. Okay, so we call it an assign. We're assigning the value of 5 into number 1. value to here. So how would we get a value in here? If we're using that convention, if we're going to do it like that, how would we get a number into here?
Number 2 equals 6.
Okay, number 2 equals 6. Cool. Then we just have total equals number 1 plus number 2, which is total equals 5 plus 6, so total equals 11. So then we print out total. What would actually print out would be the value. The value that's in total. Have I lost anybody yet? No? Good stuff. Okay. But if we do that, if we just write a sentence in our program, what happens the next time we run the program?
It's still going to think that 5 and 6 are still number 1
So
and number 2.
what's our output going to be, Jesse? I know you are, but what's the output going to be? 11. Okay, but what if we run the program again the next time? What's the output going to be? 11. But what about if we run it again? What's the output going to be?
11.
11. So this thing's bloody useless. Doing it like this is useless because every time we run it, they're the same. It's because that's the same. Because in the program we're saying, so how can we make this program a little bit better?
Do something like input dot get key. What number?
Can you just
Or
make
maybe
it,
like
hang on. You go, keep it simple, alright? How can we make the program a little bit more efficient? If we run it like that, it's always going to turn out 11. So that means we're locked into those same two numbers. What could we allow, what facility could we build in to make it a little bit more interesting? Same two guys. Louis?
To be able to clear the numbers.
Be able to clear the numbers, yeah. To be able to change. Be able to change. What do you call it in maths when you something that you can change? Something with V.
Variable.
A variable. So these are actually called variables, and they're called variables because you can vary its value. If we're not going to vary its value, it's no use having it. They actually they're then called constants because they keep that value constantly throughout the program. Okay, so we want them to be variables. So we want to be able to change these. So how could we do that? We could clear them, yeah, that's fine. So we could make, when we start off, make them 0, but how do they get the value then? What would be really good? We don't want to write the values in before it runs. Who do we want to let do the values? Oh wow, look, 2 numbers make 12. Wow, look, 2 numbers make 6. Who would we like to be able to change the numbers?
The user.
The user, yeah, just your old girlfriend, the user. I get a laugh at one. Yeah, okay, you stay, the rest go on. Okay, so we want to be able to let the user change the values. How could the user do it? By inputting, by processing, or by outputting?
Inputting.
The user could input. So what's one of our input devices?
Keyboard.
Keyboard. So we can get the user to use the keyboard to set the values. Okay. So quite often, what we can use in our pseudocode is just our generic language that we use. It's not specific to any computer language. Okay. In our pseudocode, we could say something simple like this: get number 1. Okay, and this get actually mistakes already. This get is in capital letters. It's telling us it's a doing word. Okay, it just says get the value of number 1. Or another word another word you could use might be read. Read number 1. Or input number 1. As long as they've got a similar meaning, as long as they have a meaning saying get a value, put it into here, then we're laughing. Now in Pascal, which is the language we're going to be using a lot this year, we would use read. So if we put read and then we follow it with a variable name, when we run the program, the cursor will stop at that spot. The cursor, when the processor gets to here, the cursor will stop at that spot. It'll be sitting there flashing, and then when someone types a value in and they hit enter, that value gets put in to there. So it goes into here, and that's then stored so that something can be done with it. And then we could have read number 2. And then that value gets stored in a different spot. Then we can do things with it. Have I lost anybody? Everyone okay with that?
Yep.
If we use read for input, what do you think we could use for output?
Red.
That's good. Not too bad. At least you think you had a go instead of sitting there. I don't know. That's a good one. Okay, but think about what goes with reading. Reading and writing. So if we read something, we're going in, and if we write something, we're going out. Does that make sense? So if I actually want to get this total to go to the screen, what would I write? Just said it.
Right.
Right. Right what? Capital letters for right, not capital letters for this. This has to look exactly like I've set it up at the beginning of the program. This is capital letters, right total. So my program simply would be read number 1, then
Right total.
no, read number 1,
Read number 2.
read number 2, then write total. I missed one step. Read number 1, read number 2. Yeah, okay, what's the process?
Add.
Number 1.
Yeah, it's just this. So that would be written in there. Read number 1, read number 2, total equals number 1 plus number 2, write total. There's a program already. Pretty boring, but it's a program. Okay, it's our first program we've written together. What would we have at the beginning of it? Begin. What would we have at the end of it?
End.
Notice my begin and my end very messily. They line up, okay, and then these guys line up. Yes, they're indented. Okay, now give me a break from talking and give your ears a break. Last year, when you had Taste of the Week, I touched on binary. Okay, I know that would have slipped out of your ears. From now all the way to the HSC, you need to be familiar with binary. It needs to be. You need to be able to just turn it out like that. Okay, you need to be able to recognise the binary numbers.
Oh.
You don't want to lose your phone. You need to be familiar with binary. You need to be able to recognise binary base numbers easily. You need to be able to convert from decimal to binary and back again. You need to be able to recognise the nuances, the patterns. So here's just a little explain about. Louis Irving, the only one away today again. Okay, you don't need me to read this to you, but I've tried to just make it nice and simple, nice and specific. There's a couple of activities there for you to do. If you just think about your column, your place value. And remember when you're in about year 4, you did expanded numbers. You had a piece of paper, you wrote 3,000 plus 400 plus 20 plus 1, and then you fold the paper up, so it said 3421. Okay? So whenever you get stuck, you just write your base numbers across the top. And in binary, our base numbers just double. And that's easy. Everyone knows how to double, so just remember that. Your base numbers double. 1, 2, 4, 8, 16, 32, 64, 128. They are very important numbers. You've got to burn those into your head. You have to remember what happened in the French Revolution, who led it, what the colour of the gun was. All you can do is remember 1, 2, 4, 8, 16, 32, 64, 128. I tell you, that's marks already. That's marks in your HSC. What's wrong, mate? You're too tired of later. Zoned out. Come on, try to lie out there. Are you right?
Where you fill out the
Yeah, fill it out. Have you guys, are you able to log on yet? Are you able to get access to your drives? Yeah? Okay, cool. If you want to go and turn the machine on while you're working on this, that's okay. What's your brother doing these days?
He's got a full-time job over here.
Yeah, I know. He had the baby when he was here, didn't he?
They're still together.
You're enough away.
They've got a house in Russell Lee.
Where's that?
Balmain. It's near Balmain.
Oh, okay.
It's across the
How old's the baby? It'll be about a year.
a year and a half.
You said much?
Yeah. Every week.
Yeah. Yeah, sure can. I love it. I love it when you have a go and question, and I love it when you ask for help.
Write that backwards, right?
Okay, so here's your columns here. So you have 0 there.
Oh, that makes sense.
So you're right.
So the easiest way to do it is up in the last
Okay, so zeros are off and ones are on. You write your 2048 sequence.
What?
Haven't you played the game 2048? It's like
Yeah, I
1, 2, 4. Yeah.
I played it. I know it was.
Yeah, you just write the pattern out, and then when there's a 1, so that's gonna be on, that's off, fulls off, 8's on, 16's on, 32's off.
How do you know the numbers are?
On. What?
So, 1, that's on.
That's on because there's a 1.
And 0, it's off.
Off. And then 8's on and 16's on because they're 1, 1, 0, so that's off. And 1,
Don't get
1.
lost into the
How do you
computer
sum
side.
the
Come on,
number?
Eli, you gotta
And
get
then
your
you
sheet
plus
done,
it.
mate. You done it?
No.
Okay.
So can I get help?
Yes,
I
mate.
think that's how you do
I don't
it.
know if I'm qualified to give you the help you need, though.
How do you say the first one then? How did you sum the first one?
First one. Off, on, off, on. Plus those 2. 1, 2, 3, 4.
Is that how you do it?
Yep. This one's just 2. On. One, two, three, four. and that's one.
Yeah. Look, you know what it is? You've learned numbers since you were babies. You learned base 10 since you were babies. Every number stuff you've done is base 10. And all of a sudden, you're thinking completely different. And that's all. It's not hard. It's just not what you do. And it just doesn't seem to make sense yet. It's a bit like somebody saying, oh no, you walk backwards. You know what? If I said, go to there, oh, that's easy for me to go to there. You actually do it backwards. You've got to be conscious of it, stop and think. So all you're doing, you're just doing the same thing, you're just doing a different thing. And if you're having trouble, it's not because you're dumb. It's not because it's hard. It's just that it's different and it's something new. And it's just a different way of thinking. And as I said to you, we've got to get au fait with it. So I touched on this back at Post a week, and I'm probably bored some people already. But the thing is, if we don't do this, this is a simple skill that will cost you marks. Okay? And we can do this. This is marks for you. You've got over those guys out at Blacktown, or the guys up at Wyong, or guys even the Christian Brothers Limited. There's three of them sitting at the back talking instead of listening. How'd you go with this one? I can't read that, mate.
It was 283. Second one, 283.
Second one.
Yeah, how did you do that?
1 plus 2
Yeah.
plus 16 plus 32. Did you?
What about the one at the end?
Oh wait, yeah, I did plus that.
It was 1, and then 2, and then 8.
1 plus 2 plus 8 plus 16 plus skip 1 2 8 1 2 8 yeah. Skip
1 2 1.
1 2 skip 8 16 skip
Oh, wait, hold on. What was it?
155.
Awesome.
Easy. There's a second side. Can you hurry it up? I need to do the second side.
17. 2.
Finish your sheet, Eli? Finish your sheet. Some guys have finished the whole sheet.
Wait, can we do both sides now?
Yes.
Oh, there's another side.
Oh, that is.
Don't worry, I can like space a little.
So once you log into the system, if you saved onto a USB or your phone or you email to yourself, if you can create a folder called SDD in your own drive, dump that stuff that you worked on the last 2 lessons in there.
Have an attempt at writing the number 1 to 10 in other bases. What other bases? Do you know how to do that one? You have to know this, man. It's in the test. 6 ones. It all has 6 numbers. I'm gonna do it in binary because it's symbols. 1, 2, 3. 1, 2, dot. 1, 2, 3. 1 dot. What? I don't know. I'm just doing it because 4 different ones. So.
Well, you can go higher, but 64 won't go in.
Yeah, I know.
32 will go into it, won't it? 63 should be a no-brainer. Okay, for these numbers, 3, 7, 15, 31, 63, 127, they're all ones. So if you take 1 off the base number, they're represented by all ones. Because you've used up all your combinations, so you've got to start a new column. So 15 is 1 short of 16. So it's 1, 1, 1, 1. 31 is 1 short of 32. So 32 would just be 1 and zeros. 31 is 1, 1, 1, 1, 1. You finished, Louis?
I'm just curious.
Yeah, you just pick a base yourself. You can do base 7 or base 3 or base 6 or base 2 or you're going to base 4, base 5.
Do you know any other bases? Is it base 2?
You didn't do it. No, that's what you're doing. Guys, I'll give you a tip. If your writing is that bad someone can't read it, if the examiner can't read it, you're just throwing away marks. Okay, so if you've got really bad handwriting, work on it, because when you do your exams, they're all theory, they're all based on paper. Your examiner will be marking you. If they can't read it, they're just going to give you 0. And you might have answered the question fully. Okay? Unless you've got special provisions and you're going to be using a laptop, work on your handwriting. Okay? Someone just comes down to be lazy. You're taking back up playing with a chair. So you got to do this. make up your own bases you want to use. Just pick base 3 or base 7 or base 8 or base 6, whatever, and see if you convert those numbers into bases. Most of them, they're just going to be 1. If we have base 3, we're using the numbers 0, 1, 2. If we have base 4, we're using the numbers 0, 1, 2, 3. If we have base 5, we're using the numbers 0, 1, 2, 3, 4. So if you do base 5, your first 4 numbers are going to be the same as decimal. If you do base 7, your first 7 numbers are going to be the same as decimal. I should say your first 6. We'll put the 0 on. Pick a base and a whole one. So 1 is base 6.
2800.
So this base 6 you can use the numbers 0, 1, base 2, base 1, base 8. So 1 is still 1. 2 is still 2.
Are you checking it like today?
You can't write 6. 0, 1, 2, 3, 4, 5, 6. What do you think? So what are we doing?
Oh my God.
Which end of the form?
Yeah, looking at grades on 8, 7.
What do we do when counting?
What will we do? We'll do which end of the column? 1, 2, 3, 4, 5, 6, 9.
500.
That'll be right 10.
500 what?
1, 0. So you have 0 in the last column.
I don't know, I'm wrong.
So then you've got 1, 6, and 9. 1, 2, 3, 4, 5, 6, 11. Base 6.
I think I'm wrong.
When you're doing your base, whatever base you do, 0 is box. Base 10, base 2, that's 2. Okay, so now 7 would be.
I think I got it.
Good. Okay, then just pick another one. Do base 1, 9 or 3. Okay, now, the smaller this number is, the less symbols we've got. So you're only going to get to do 1. So you're going to get this.
I don't know why, but I just think it's like that.
Oh, what are you doing? Well, you asked me for help. No, but you're just copying them. Okay. Hey guys, can I just say, in this course, we seem to have, this happens every year, we get a few people that go, well, how do you do it? And they just copy off the people next to them, and then after about 3-4 months they go, oh, I don't get it. If you don't get it now, you've got to ask. So these guys at the back, they're asking for help. Belly straight away, ask for help. You're going to learn, right? You're going to progress, and you're going to do okay. If you're too scared to ask for help, if you're going to copy off someone next to you, you're going to fail. I'm telling you now. If you go and play a sport, if the coach says to you, go run around the field 3 times and go practice your goal kick, and you say to your mate, can you do it for me? You're not going to get fit. You're not going to learn anything. And when we start writing code, if you don't know how to do it, please don't just write it off the guy next to you. Don't copy. And those guys that know how to do it, I will kick you up the backside if you start saying to the guy, this is how you do it. Okay? Do not just show them and do not do it for them, because they will not learn anything. If that was how we're going to learn, I would just do that for you. I just write it for you. Okay? Guy, you're starting to annoy me, mate. Fiddler and a floater, a meanderer, anything putting a yarn on the end. Yeah. Pick a number. Right through. Okay, so you can only use the numbers 0, 1, 2, because that's your 3 you're using. Okay? You've only got 3 symbols in base 3. 0, 1, 2. So 1 is written as 1. 2 is 2. And then we can't write 3 because we've already used it. Not 1, 2. How do you write 10? 1, 0. So in base 2, that is not 1, 2. Okay.
I don't know reader.
Base 3, not 1, 3, no 1. Okay, so 1, 0 is always the base number. Or whatever base you're in is the base number. Does that make sense? 1, 0. Always. That's right. It's not divided by the base. So you get 1 on those. That's the 10. So 1, 0. So now base 10, base 10, that is 10. But in 2, that's base 2. Base 3, that's number 3. Base 5, that's number 5. So the next number is 1, 0, but you've used number 3. So 3 is 1, 0. Okay, so now you add 1 to that. 4. That's right. Then you add 1 to that, we get 5.
Then what do I do if I want to change it?
Why would you? Well, add 1 to that. So, how do I write that? No, okay, add 1 to that. What's 1 plus 1? Okay, so when you add 1 to that, you get 1, 2. 1, 2, 1. So we've already got 1. Yes. 1, 2, 3, because you've got 1, 3. That's 4, you've got 1, 3, 1, 1. 5, 1, 3, 2. Just 1, 2. You're the first grade, yeah? You're allowed to use the numbers 0, 1, 2. Yeah. 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. The next one. He's close. 2. When we get to 9, what's the next thing? What's the number in a column? Okay. Try another one. Try to say 6 or 7 plus. Have you transferred your... I don't mind you having your music on, okay, but I don't want you to be texting and WhatsApps and kicking and Snapchatting and tumbling, twerking, tweeting. What's that other one where you're Facebooking? Twerk. What's the other one where you make people by the way they look? No. Are you on that stuff? Oh, yeah. What do you call them? What do you call them? Tinders, do you? I mean, Tinders, you get can you write somebody? Can you write somebody you suck while they go with you? Yeah. That's what I'm getting. Hey, old man, what are you?
Yeah, but it's like...
No, you're not allowed to be on social network except for Facebook. Will you leave the chubby glare of that? Have you finished your shit?
I just want to know if that one's
Is
good.
that base 6?
Yeah.
1, 2, 3, 4, 5. Beautiful. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. Excellent. Base 9, 1, 2, 3, 4, 5, 6, 7, 8, 1. Yeah. Okay. Whatever your base is, that number is always 1, 0. So base 9, that's 1, 0. Base 8, that should be 8's 1, 0. Base 2, 1, 0 is 2.
Yep.
You get me? You get what I mean? Because you've gone through your column once. Okay, and when we do like say base 4, 1, 4. Okay? 1, 0 is 4. If that was base 5, this number would be here, 1, 0 is 5. If that was base 6, 1, 0 is 6. You get that? So gone through once, you start at the top, you start at the back. Gone through all your symbols once. Okay, so base 4, the first number's 9. What I should have done is 0. Because you can use 0, 1, 2, 3. There you go, 4 numbers. Okay, so what's your next one? Yep. Next one. Yep, now you can't write your number 4. I just showed you how to write number 4 in base 4. You've gone through once, so put a 0. Yep, and a 1 next to it because you've gone through once. Now starting again. So add 1 to that. That's 4 and nothing. That's 4 and 1 is 5. Yep. Yep. And then gone through twice. So what's the number here? 8. So your numbers in base 4. You want to write 8. How many 4s in 8?
I reckon she's in everything.
Why is it?
Yep.
Alright guys, if you've transferred your stuff over to your folder, you can log off and go. You guys haven't even logged on yet.
Yes, sir.
I transferred my stuff in study period.
If you haven't finished that sheet, finish it for home, please. You've got me tomorrow, I'm pretty sure. Yes?
So why do you make us log on?
To transfer that stuff into your folder. You can do it because you're too busy going.
That's me.
You know the stuff you worked on last week?
Yes, I asked you to transfer that to your home. I asked you to create a folder for this group.
See you guys.
And then save that folder. Okay, all right.
Yeah, and I was going to get you to do a little bit of programming. So tomorrow I might do some programming. Okay?
See you later.
See you, mate. Okay, take it. All right. Just
Like, what, has it got a name?
this bit.
See you, sir.
We're just writing numbers in there.